In the vast tapestry of scientific advancement, no discovery exists in isolation. Instead, these breakthroughs intertwine, forming an intricate web of knowledge that grows increasingly complex with every passing year. Quantum technology, for instance, owes much of its rapid development to the profound insights gleaned from astrophysics. The revelations from distant stars and cosmic phenomena inform and inspire new methods of manipulating matter at the smallest scales. Meanwhile, revolutionary progress in medicine is fueled by innovations in materials science, the creation of novel substances capable of adapting to biological environments, thus opening new frontiers in treatment and healing. Likewise, archaeology has been transformed through the integration of artificial intelligence, enabling researchers to analyze and interpret vast troves of data with unprecedented speed and accuracy. This interconnectivity exemplifies the very essence of knowledge evolution, a dynamic, ever-resonating process where each advancement in one field becomes a catalyst propelling progress in others. Humanity, a product of nearly 14 billion years of cosmic evolution, finds itself at the nexus of this intellectual convergence. We have become storytellers, decipherers of the universe's secrets, and, potentially, architects of its destiny. From the tiniest specks of dust scattered across interstellar space to the most profound ideas conceived within the human mind, all are parts of this ceaseless flow, a continuous current of creativity, discovery, and understanding. This ongoing saga, the greatest ever told, unfolds daily through the relentless efforts of humankind as we explore and comprehend the universe we call home. Recent discoveries have illuminated this cosmic narrative further. In the seemingly empty void between galaxies, cutting-edge X-ray telescopes have revealed vast, tenuous filaments of superheated gas extending millions of light years, constituting the cosmic web that interlinks the universe's largest structures. These filaments harbor baryonic matter 10 times the combined mass of all known galaxies, finally resolving the decades-long enigma of the missing matter in the cosmos. More intriguingly, data from missions like Rosetta show how energy traverses this intricate network, painting a picture of the universe as a far more interconnected and dynamic entity than previously imagined. Not merely isolated clusters of galaxies, but a vibrant and living web of matter and energy. Parallel to these cosmic explorations, quantum physicists in laboratories on Earth have created entirely new states of matter. These quantum supermolecules consist of hundreds of atoms sharing a collective quantum state in 3 dimensions, simultaneously exhibiting properties akin to solids, liquids, and gases. This unprecedented phenomenon challenges existing theories in condensed matter physics and heralds a new era of smart materials that can alter their properties on demand in real time. The potential applications are vast, from biomedical materials that adapt to their environment to architectural frameworks that respond dynamically to seismic activity, to energy solutions involving room temperature superconductors, and multifunctional consumer electronics capable of feats unimaginable until now at the ocean's deepest trench. Scientists have uncovered thriving ecosystems of ancient bacteria, record-breaking depths exceeding 11,000 meters, in conditions of pressure strong enough across modern military submarines. These microorganisms subsist entirely independent of sunlight, harnessing energy from serpentinization reactions between mantle rock and seawater. This discovery expands the known boundaries of life on Earth and strengthens a hypothesis that similar life forms could exist beneath the icy surfaces of moons like Europa. Notably, these bacteria produce enzymes that degrade plastics at rates 5 times faster than surface bacteria, offering a promising solution to the global plastic pollution crisis. Simultaneously, artificial intelligence is revolutionizing medicine with tools like AlphaFold 4, which can predict protein structures and their interactions with DNA and RNA with remarkable precision. This breakthrough drastically reduces drug development times from a decade to mere months and enables the design of entirely new proteins. One standout application is an enzyme capable of decomposing PET plastic within 24 hours. A staggering improvement over the 450 years it takes naturally, representing a pivotal advance in tackling plastic waste. In the realm of energy, the spark fusion reactor has achieved a milestone by sustaining plasma at 200 million degrees Celsius for 55 seconds, producing 10 times the energy input. This progress brings humanity closer to harnessing a virtually limitless source of clean energy. Emulating the processes powering the sun, such technology promises to revolutionize energy production, addressing climate challenges without carbon emissions. Meanwhile, the James Webb Space Telescope continues to challenge cosmological models by discovering galaxies that seemingly should not exist. Massive collections of stars formed a mere 200 million years after the Big Bang, with masses surpassing our Milky Way by 100-fold. These findings compel scientists to reevaluate current theories on the formation and evolution of the universe, questioning the completeness of the standard model of particle physics. On the International Space Station, the Cold Atom Lab experiment has, for the first time, observed quantum entanglement between atoms separated by 1.5 meters in microgravity. This breakthrough paves the way for a quantum communication network in space, potentially forming the backbone of an ultra-secure, high-speed quantum internet far surpassing present capabilities. Collectively, these diverse yet interconnected advancements compose a complex web of knowledge, astrophysics pushing quantum technology forward, new materials catalyzing medical breakthroughs, AI revolutionizing archaeology and biology. This is the fundamental nature of intellectual evolution, a constant synergy where each breakthrough acts as a lever for others. Humans, shaped by 13.8 billion years of cosmic evolution, increasingly assume the roles of interpreters and shapers of universal destiny. From interstellar dust grains to humanity's grandest ideas, all are elements of an eternal current of knowledge, an unending journey to explore and understand the cosmic home we inhabit. In the vast tapestry of scientific progress, no advancement exists in isolation. Instead, each breakthrough intertwines, creating an ever more complex web of knowledge. Quantum technology thrives on deepened insights into astrophysics. Revolutionary medical treatments emerge through novel materials engineering. Archaeology leaps forward powered by artificial intelligence. This interconnected evolution is the essence of knowledge advancement, a continuous resonance where every step in one domain propels others forward. In this magnificent flow, humanity, the product of 13.8 billion years of cosmic evolution, gradually becomes the storyteller, the decoder, and, perhaps, in the near future, the architect of the universe's destiny. From microscopic dust particles scattered between stars to humanity's grandest ideas, from the simplest chemical reactions in primordial oceans to today's sophisticated quantum supercomputers, all form parts of this eternal current, the current of creativity, discovery, and understanding. Thus, the greatest story ever told continues to be written each day through the relentless efforts of all humanity in the quest to explore and comprehend the universe we call home. In the seemingly empty voids between galaxies, the latest X-ray telescopes have uncovered tenuous filaments of hot gas, millions of degrees in temperature, and stretching across millions of light years, dubbed the cosmic backbone. These structures connect the universe's largest formations. These gaseous strands hold baryonic matter amounting to 10 times the total mass of all galaxies combined, solving the long-standing mystery of the missing matter that puzzled scientists for decades. Even more striking, data from the Rosetta Observatory reveals how energy travels throughout the cosmos via this intricate network, showing the universe to be a far livelier network than the isolated galaxies we once imagined. Meanwhile, quantum physicists in laboratories have created a completely novel state of matter, the quantum supermolecule, where hundreds of atoms share a single quantum state within three-dimensional space. This state exhibits properties reminiscent of solids, liquids, and gases simultaneously. Such unprecedented phenomena challenge existing condensed matter physics theories and pave the way for intelligent materials that can adapt their properties in real time. The potential applications span medicine, self-regulating biomaterials, construction structures adaptive to seismic activity, energy room temperature superconductors, and consumer electronics multifunctional devices. Deep in the Mariana Trench, scientists have discovered an ancient bacterial ecosystem thriving at the record-breaking depth of 11.0 meters, where pressures would crush military submarines. Astonishingly, these organisms exist entirely independent of sunlight, instead deriving energy from serpentinization reactions between the mantle's rocks and seawater. Not only does this extend the known limits of life on Earth, but it also strengthens the hypothesis that life could exist beneath the icy crusts of moons such as Europa. Remarkably, these bacteria produce enzymes that degrade plastic at a rate 5 times faster than terrestrial microbes, offering a promising solution to the global plastic pollution crisis. Artificial intelligence is revolutionizing medicine with AlphaFold 4, which not only predicts protein structures with unparalleled accuracy, but also their interactions with DNA and RNA. This breakthrough shortens drug development from a decade to mere months and enables the design of entirely new proteins. A standout application is an enzyme capable of degrading PET plastic within 24 hours compared to the 450 years it naturally takes. A major advance in plastic waste management. The spark fusion reactor has achieved a milestone by sustaining plasma at 200 million degrees Celsius for 55 seconds, producing 10 times more energy output than input, a critical leap toward clean, limitless energy mimicking the sun's operation. This technology promises to revolutionize the energy sector, addressing climate crises without harmful emissions. The James Webb Space Telescope continues to overturn cosmological models by discovering impossible galaxies formed just 200 million years after the Big Bang, but possessing masses 100 times greater than the Milky Way. These findings force scientists to reconsider the entirety of cosmic formation theories, even questioning the completeness of the standard model of particle physics. On the International Space Station, the Cold Atom Lab has for the first time observed quantum entanglement between atoms separated by 1.5 meters under microgravity conditions, opening pathways to space-based quantum communication networks that could vastly outperform today's internet in speed and security. These advances interweave into a complex network of knowledge. Astrophysics propels quantum technology. New materials revolutionize medicine. AI transforms archaeology. This is the essence of knowledge evolution, a continuous synergy where every breakthrough becomes a lever for others. Humanity shaped by 13.8 billion years of cosmic evolution is increasingly the decoder and shaper of the universe's destiny. From interstellar dust to the grandest ideas, all belong to this eternal current of knowledge, a never-ending journey of exploration and understanding of our cosmic home. As we delve deeper into the labyrinth of cosmic knowledge, the pattern of interdependence among various scientific fields becomes ever clearer. No discovery stands alone. Each breakthrough acts as a seed, sprouting ideas and innovations across disciplines. This is the hallmark of a knowledge ecosystem, a living, breathing network where astronomy enlightens quantum mechanics, new materials reshape biology, and computational intelligence transforms humanity's. Quantum mechanics, once a realm of abstract theory, has now been propelled into practical realms due to astrophysical discoveries. Understanding the behaviors of particles in extreme environments, such as those near black holes or in the early universe, has informed the creation of quantum devices that manipulate information in ways unimaginable mere decades ago. The development of quantum computers and sensors has ushered in a new era of precision measurement and data processing, revolutionizing fields from cryptography to climate modeling. In parallel, materials science breakthroughs powered by quantum theory and nanotechnology are fueling a renaissance in medicine. Smart materials that respond dynamically to environmental stimuli enable innovation such as self-healing tissues, targeted drug delivery systems, and implants that adapt to the body's changing conditions. These advances blur the boundary between biology and engineering, opening frontiers where living systems and synthetic devices merge. Artificial intelligence, AI, meanwhile, acts as a potent accelerator of knowledge, transcending traditional research limits. AI algorithms sift through vast data sets, uncovering patterns invisible to human cognition and generating hypotheses at unprecedented speeds. This capability has transformed archaeology by reconstructing lost civilizations and deciphering ancient scripts, while also revolutionizing genomics, epidemiology, and drug design. This intricate interplay embodies the very nature of knowledge evolution, an ongoing symphony where each instrument's note enhances the collective harmony. Just as ecosystems in nature depend on the interactions among species, the intellectual ecosystem thrives on cross-disciplinary fertilization at the human level. This dynamic network of knowledge has propelled us from mere survivors to cosmic storytellers and architects. We have learned to read the cosmic scripts embedded in starlight and gravitational waves, decoding the universe's past and predicting its future. We have harnessed atomic and subatomic forces, reshaping matter and energy. Yet, more profoundly, we are beginning to understand our place as conscious agents within this vast expanse. The discovery of the cosmic web, the vast filaments of matter that form the universe's large-scale structure, redefines our cosmic perspective. No longer are galaxies isolated islands. Instead, they are nodes connected by vast strands of gas and dark matter, a dynamic network conveying energy and information across unimaginable distances. This revelation paints the universe as an intricate, interconnected organism, one where change in one region resonates across the cosmic fabric. Meanwhile, the creation of quantum supermolecules, combining traits of solids, liquids, and gases, opens pathways to materials that can sense, adapt, and respond in real time. Imagine buildings that automatically adjust their structural properties to withstand earthquakes, or medical implants that modulate their functions based on the body's needs. Such materials could herald a new era of responsive, sustainable technology, deeply integrated with human life and the environment. In Earth's deepest ocean trenches, extremophiles surviving crushing pressures and darkness challenge our understanding of life's limits. These microorganisms' ability to thrive via chemical reactions independent of sunlight suggests life's potential ubiquity in the universe, whether beneath icy moon surfaces or in subterranean caves on distant planets. Moreover, their ability to rapidly degrade plastics points toward sustainable solutions to humanity's mounting environmental crises. Artificial intelligence's role in accelerating protein structure, prediction, and drug design marks a turning point in medicine. By reducing development cycles from years to months, AI-driven platforms enable rapid responses to emerging diseases and personalized treatments. The creation of enzymes that degrade persistent plastics rapidly signals a paradigm shift in environmental remediation, addressing one of the most daunting challenges of modern civilization. Energy, the lifeblood of human progress, is also on the cusp of transformation. Achievements in fusion technology, such as sparks record-breaking plasma confinement, bring the dream of clean, limitless energy closer to reality. Replicating the processes powering the sun offers a sustainable alternative to fossil fuels, with the potential to mitigate climate change and power future generations. The James Webb Space Telescope's identification of massive early galaxies forces scientists to rethink cosmological models, highlighting the universe's complexity and the limits of current understanding. Each surprising discovery compels refinement of theories and inspires new questions, reflecting science's evolving, self-correcting nature. Finally, experiments in microgravity quantum entanglement point toward a future of ultra-secure communication networks spanning Earth and space. Such technological frontiers promise to redefine connectivity, privacy, and information exchange, underpinning the digital infrastructures of tomorrow. together. These scientific milestones compose a grand mosaic of human ingenuity and cosmic interaction. They illustrate how knowledge evolves through collaboration across disciplines and cultures, powered by curiosity and creativity. Humanity stands at the nexus of this cosmic web, capable of interpreting its signals and, increasingly, of shaping its future trajectory. The journey from stardust to sentient beings is more than a narrative of survival. It is a testament to the power of interconnected discovery. As we continue to unravel the universe's mysteries, each revelation not only expands our scientific horizons, but deepens our understanding of what it means to be part of this vast, magnificent cosmos. In the vast expanse of cosmic evolution, the progress of human understanding resembles a vast tapestry woven with threads from countless disciplines. These threads, once separate and distinct, have increasingly intertwined, creating patterns of knowledge that are far more intricate and robust than any single strand could achieve alone. This synthesis embodies the very essence of scientific progress, a coalescence of ideas, discoveries, and technologies that build upon each other to propel humanity forward. Consider, for instance, the interplay between astrophysics and quantum mechanics. Insights gleaned from observing phenomena such as gravitational waves and black hole event horizons have illuminated aspects of quantum entanglement and particle behavior at cosmic scales. This convergence not only deepens our grasp of fundamental physics, but also catalyzes the development of quantum technologies that promise to revolutionize computation, communication, and sensing. Similarly, materials science infused with knowledge from chemistry, physics, and biology has birthed innovations that redefine what is possible in medicine, engineering, and environmental stewardship. Advanced biomaterials inspired by quantum supermolecules offer unprecedented adaptability, allowing devices and implants to interact seamlessly with biological systems. These materials can respond dynamically to stimuli, self-repair damage, or change properties on command, opening horizons for personalized medicine and sustainable architecture. The contributions of artificial intelligence further underscore the accelerating pace and complexity of knowledge integration. Machine learning algorithms capable of analyzing massive data sets across multiple fields facilitate discoveries that would be otherwise unattainable. From reconstructing ancient civilizations with archaeological AI to designing novel proteins for pharmaceutical applications, AI acts as an intellectual multiplier, expanding human cognitive reach. These advancements are not isolated feats, but components of a self-reinforcing cycle. Progress in one domain catalyzes breakthroughs in others, resulting in a cascading effect of innovation. This symbiotic relationship is the hallmark of the knowledge ecosystem, a dynamic, evolving web where each node represents a domain of expertise, and each connection facilitates the flow of insight and discovery. At the heart of this web is humanity itself, the inheritor and steward of cosmic knowledge, emerging from 13.8 billion years of cosmic evolution. Humans uniquely possess the capacity not only to comprehend the universe, but also to influence its future trajectory. This responsibility carries profound implications. The recent revelation of the cosmic web, vast filaments of matter threading the universe, invites us to perceive the cosmos as an interconnected organism rather than a collection of isolated bodies. This insight transforms our cosmological perspective, suggesting that the universe's evolution is shaped by the continuous exchange of matter, energy, and information across these vast networks. Parallel developments in material science, such as the creation of quantum supermolecules, hold promise for technologies that can adapt in real time to their environment. Such advancements imply a future where human habitats and tools are not static but responsive entities, capable of evolving alongside the changing conditions of our planet and beyond. The discovery of resilient microbial life thriving in Earth's most extreme environments challenges long-held assumptions about the limits of life. These extremophiles' ability to metabolize without sunlight points to the possibility of life existing in subsurface oceans of icy moons or beneath planetary crusts, expanding the scope of astrobiology, cow research, and fueling the quest for extraterrestrial life. Artificial intelligence's rapid progress in decoding biological structures and interactions revolutionizes medicine, enabling swift drug development and tailored therapies. The design of enzymes capable of degrading persistent plastics represents a critical breakthrough in addressing environmental pollution, emphasizing the role of biotechnology and sustainability. In energy, the achievements in fusion research symbolize a turning point in humanity's quest for clean, inexhaustible power. Replicating stellar processes on Earth could finally free society from the shackles of fossil fuels, mitigating climate change and powering future civilizations. The James Webb Space Telescope's unexpected findings challenge prevailing cosmological theories, underscoring the ever-changing nature of scientific understanding. Each anomaly demands new hypotheses and deeper inquiry, illustrating science's iterative nature and the humility required to embrace uncertainty. Experiments in quantum entanglement under microgravity conditions pave the way for revolutionary communication systems that transcend current limitations, heralding an era of secure, high-speed data transmission vital for future interplanetary exploration and connectivity. Collectively, these discoveries and innovations paint a portrait of an evolving cosmos intimately linked with human ingenuity. The mosaic of knowledge they compose is a testament to the power of collaborative inquiry and the boundless potential of the human mind. As we stand at this crossroads, the role of humans transcends that of passive observers. We are becoming active participants, cosmic storytellers, and architects of the universe's unfolding narrative. Our ability to decode the cosmic language grants us insights into the fundamental workings of reality, while our technological prowess equips us to shape environmental, societal, and even cosmic futures. This dual role carries both opportunity and responsibility. The same knowledge that enables transformative progress also demands ethical reflection and stewardship. As we manipulate matter, energy, and life itself, we must consider the implications of our actions on planetary and cosmic scales. The journey from stardust to sentience is ongoing, marked by continual expansion of understanding and capability. Each scientific breakthrough is a chapter in this epic tale-end exploration of the infinite, a quest for meaning and a testament to resilience and creativity. In embracing this legacy, humanity affirms its place within the grand cosmic web, not merely as an end point, but as an active node contributing to the ongoing evolution of the universe. The ever-expanding horizon of human knowledge has ushered in an era where the boundaries between disciplines dissolve, giving rise to unprecedented opportunities and challenges. As the fabric of understanding becomes denser, the capacity of humans to interact with and influence the universe grows accordingly. This evolution is not merely technological, but fundamentally philosophical. It reshapes humanity's self-conception from passive observers to active participants in the cosmic drama. The discovery of cosmic filaments, vast tendrils of matter stretching across millions of light years, offers a profound metaphor for the interconnectedness of all things. These structures, once invisible, now reveal that the universe is a dynamic network of matter and energy, continually exchanging and evolving. Recognizing this cosmic network invites reflection on our place within it, not as isolated entities, but as nodes within a grand system, linked through both physical and informational pathways. In parallel, the emergence of quantum supermolecules entities that blur the lines between traditional states of matter heralds a new frontier in materials science. These supermolecules' ability to simultaneously exhibit properties of solids, liquids, and gases opens possibilities for adaptive materials capable of responding fluidly to environmental stimuli. Such materials could revolutionize everything from medical implants that heal themselves to buildings that adjust their structure to withstand seismic activity or climate extremes. The deep-sea discoveries of extremophiles thriving in crushing pressures and complete darkness challenge conventional wisdom about the prerequisites for life. These microbes metabolize energy from geological processes independent of sunlight, suggesting that life could flourish in environments previously deemed inhospitable. This expands the scope of astrobiology and informs the search for life beyond Earth, particularly in the subsurface oceans of moons like Europa and Enceladus, where similar conditions may prevail. Artificial intelligence accelerates this process of discovery and application. AlphaFold 4's breakthroughs in protein structure prediction and interaction mapping transform drug discovery and synthetic biology, compressing years of research into months or weeks. The design of enzymes capable of rapidly degrading persistent plastics exemplifies AI's capacity to tackle global environmental crises by mimicking and enhancing natural processes. Energy research, epitomized by the progress of the spark fusion reactor, signals a turning point in humanity's relationship with power generation. Achieving sustained fusion reactions at conditions akin to the sun's core offers the promise of clean, abundant, and sustainable energy. This technology could mitigate climate change and underpin future expansions of human civilization, both on Earth and beyond. Meanwhile, observations by the James Webb Space Telescope force reconsideration of cosmological models, challenging the standard model of particle physics and cosmic evolution. The detection of massive early galaxies that seemingly defy formation theories demands new physics, new mathematics, and new imagination. This unsettled frontier fuels the engine of scientific progress, reminding us that understanding the universe is an ever-evolving journey. Quantum communication experiments aboard the International Space Station, including cold atom labs' manipulation of atomic states across unprecedented distances, demonstrate the feasibility of ultra-secure quantum networks. These technologies promise to revolutionize data security and transmission, essential for an increasingly interconnected and digital civilization and crucial for interplanetary communication in the age of space exploration. Taken together, these advancements underscore a fundamental principle. Knowledge is a living, growing network where progress in one field catalyzes breakthroughs in others. This interconnectedness defines the evolution of human understanding, creating a synergy that accelerates discovery and innovation. At the core of this network is humanity's role as both interpreter and shaper of the cosmos. We have transcended the role of mere observers, becoming storytellers who translate the universe's language, and architects who use this language to construct new realities. This transition marks a paradigm shift from understanding the universe as an external object to engaging with it as a malleable, dynamic system. This evolving role carries profound ethical and philosophical responsibilities. As creators and modifiers of matter, energy, and life, humans must balance ambition with caution, innovation with stewardship. The choices we make today will echo across epochs, influencing not just our planet, but potentially the universe itself. From the primordial dust that coalesced into stars to the complex ecosystems of Earth and onward to the intricate web of human knowledge, the journey of existence is marked by an unending quest for understanding and mastery. Our advancements in science and technology reflect a deep-seated drive to unravel the mysteries of reality and to assert our agency within it. The implications of this journey extend beyond scientific inquiry. They challenge humanity to rethink its relationship with nature, technology, and the cosmos. They call for a new narrative, one that embraces complexity, interconnectedness, and the potential for profound transformation. As we harness the power of quantum materials, explore the deepest oceans, decode the language of proteins, and peer into the furthest reaches of space, we are also crafting a story of emergence. This story is not just about atoms and galaxies, but about consciousness, creativity, and the collective spirit of inquiry. In this unfolding narrative, humans are not merely the product of cosmic evolution. They are agents capable of influencing the trajectory of that evolution. The line between knowledge and action blurs, making us stewards of a universe in flux. The next chapters of this epic will be written by those who dare to explore, innovate, and imagine. It is a call to all who seek not only to understand the cosmos, but to shape its destiny, a destiny that is, in part, theirs to define. The story of humanity's journey through knowledge is ultimately a story of transformation, from beings shaped by cosmic forces to beings shaping those very forces in return. This evolution is both a natural consequence of the unfolding universe and a profound mystery that calls for reflection. Each scientific breakthrough, whether it be the detection of the cosmic web's filaments, the creation of quantum supermolecules, or the discovery of extreme life forms in Earth's deepest trenches, is not isolated but entwined with a larger tapestry of understanding. These milestones do not merely add to the body of knowledge. They change its structure, its texture, and its potential. The cosmic filaments themselves, the vast strands of matter stretching across unimaginable distances, are a reminder of the universe's deeply interconnected nature. They form the scaffolding upon which galaxies are arranged, channels through which matter and energy flow, and a dynamic system that constantly evolves. This cosmic network reflects patterns found on much smaller scales, from neural networks in the brain to the web of life on Earth, hinting at universal principles of connectivity and complexity. Meanwhile, the advent of quantum supermolecules represents a new paradigm in the physical world. These entities challenge the classical categorization of matter, existing simultaneously in states that defy intuition. The ability to engineer materials with such fluid properties opens doors to innovations in medicine, architecture, and technology that were previously relegated to science fiction. On Earth, the discovery of microbial ecosystems thriving without sunlight, using chemical energy from Earth's mantle, expands the boundaries of life itself. This forces scientists and philosophers alike to reconsider the conditions necessary for life and the possibilities of life elsewhere in the cosmos. If life can thrive in crushing pressures and complete darkness, the potential habitats for life are far more diverse than once imagined. Artificial intelligence stands at the nexus of these discoveries and their applications, with tools like AlphaFold 4, which can predict protein structures with remarkable accuracy. The pace of biological and medical advances has accelerated exponentially. The design of enzymes to degrade plastics in record time is a testament to the power of combining computational insight with biological innovation, offering hope for solutions to some of the planet's most pressing environmental issues. Energy research, exemplified by fusion reactors like Spark, points toward a future where humanity's energy needs are met sustainably with minimal environmental impact. Fusion energy, harnessing the processes that power stars, promises to redefine how societies generate and consume power, potentially freeing future generations from the constraints of fossil fuels and associated climate threats. The James Webb Space Telescope's discoveries continue to challenge and refine cosmological theories. Observations of unexpectedly massive early galaxies suggest that our understanding of the universe's infancy is incomplete, pushing researchers to develop new models that incorporate unknown physical processes. This evolving picture is a vivid illustration of how each answer leads to new questions, driving the scientific endeavor forward. Quantum communication advancements, such as those tested on the International Space Station, are laying the groundwork for an era of information technology that is radically more secure and efficient. As the digital infrastructure of humanity expands into space, these technologies will become essential for maintaining connectivity and security across vast distances. Together, these threads weave a narrative of a universe not static or simple, but dynamic, complex, and deeply interwoven. Knowledge grows not linearly, but as a fractal, expanding in complexity and richness with each discovery. At the heart of this story is the evolving role of humanity. No longer mere inhabitants of a passive cosmos, humans are becoming active agents of change, wielding knowledge and technology shape environments, create new forms of life, and explore realms beyond our planet. This transition carries profound responsibilities. The power to alter ecosystems, to create or eradicate species, to harness immense energies, demands wisdom and foresight. Ethical frameworks must evolve alongside technological capabilities to ensure that progress benefits all life and preserves the integrity of natural systems. Philosophically, this shift invites reconsideration of humanity's place in the universe. We are both products of cosmic evolution and co-creators of its future trajectory. The universe, once seen as an indifferent expanse, is now perceived as a participatory arena where conscious beings influence its unfolding story. As we stand on this threshold, questions arise. How will we balance exploration with preservation, innovation with responsibility, knowledge with humility? The journey ahead is as much about inner transformation as it is about external discovery. Understanding the cosmos requires not just telescopes and equations, but also empathy, ethics, and imagination. The intertwined progress of science and human consciousness suggests a future where the boundaries between observer and observed blur. As we learn to manipulate quantum states, create synthetic life, and communicate across vast cosmic distances, we become entwined with the universe's fabric in unprecedented ways. This emerging cosmic agency calls for a new narrative, one that honors the legacy of billions of years of evolution, recognizes the interconnectedness of all things, and embraces the potential to shape the destiny of life and matter across the cosmos. It is a story still being written by every discovery, every innovation, every act of stewardship, and every moment of insight. The infinite web of knowledge is both a map and a mirror, reflecting the universe's complexity and humanity's evolving place within it. In the intricate web of modern scientific progress, breakthroughs do not exist in isolation. Rather, they are interwoven, creating a complex and ever-expanding tapestry of knowledge. Quantum technologies, for instance, owe their rapid advancement to deeper insights gleaned from astrophysics, while revolutionary medical treatments emerge from novel material sciences, and archaeology is being transformed by cutting-edge artificial intelligence techniques. This interconnectedness embodies the essence of knowledge evolution at continuous resonance, where each advancement in one domain acts as a catalyst, propelling others forward. At the heart of this grand narrative is humanity itself, a species shaped by 13.8 billion years of cosmic evolution, now increasingly becoming not only observers and interpreters, but also architects of the universe's destiny. From microscopic dust particles drifting between stars to the grandest human ideas conceived in the mind, and from the simplest chemical reactions in ancient oceans to state-of-the-art quantum supercomputers, all belong to an eternal flow of creativity, discovery, and comprehension. Recent observations by the latest X-ray telescopes have unveiled diffuse, scorching hot gas filaments stretching across millions of light years, forming what scientists describe as the cosmic backbone that links the largest structures in the universe. These gaseous strands contain baryonic matter totaling 10 times the mass of all galaxies combined, resolving a mystery that had baffled astrophysicists for decades. The location of the universe's missing matter, More intriguingly, data from the Rosetta mission reveal how energy propagates across the cosmos through this intricate network, painting a picture of the universe as a far more dynamic and interconnected entity than the discrete galaxies we once imagined. Meanwhile, in quantum laboratories on Earth, physicists have synthesized an unprecedented state of matter known as a quantum supermolecule, wherein hundreds of atoms share a collective quantum state within three-dimensional space. This exotic matter exhibits simultaneous characteristics of solids, liquids, and gases, challenging established theories of condensed matter physics. The potential applications are revolutionary. Smart materials that dynamically adjust their properties in real time could transform healthcare through bioadaptive materials, enhance infrastructure with earthquake-resistant constructions, advance energy technologies via room temperature superconductors, and revolutionize consumer electronics with multifunctional devices deep beneath the surface of the Earth. Within the crushing pressures of the Mariana Trench at depths exceeding 11 kilometers, scientists have discovered thriving ecosystems of ancient bacteria. Remarkably, these microorganisms exist without reliance on sunlight, instead harnessing energy through serpentinization reactions between mantle rocks and seawater. This discovery not only pushes the known boundaries of life on Earth, but also reinforces hypotheses about possible life beneath the icy crusts of moons like Europa. Even more promising is their ability to produce enzymes that degrade plastics at rates 5 times faster than surface bacteria, offering a potential natural solution to the global plastic pollution crisis. Artificial intelligence is simultaneously revolutionizing medicine. The latest version of AlphaFold, Version 4, has surpassed expectations by accurately predicting protein structures and their interactions with DNA and RNA. This breakthrough has drastically shortened drug development timelines from a decade to mere months, enabling the design of entirely new proteins, notably engineered enzymes capable of decomposing PET plastics within 24 hours versus for 150 years, actually herald a new era in waste management. Energy technology has also taken a giant leap forward, with the spark fusion reactor maintaining a 200 million degrees Celsius plasma for 55 seconds, producing tenfold the energy input. This milestone represents a crucial step toward limitless, clean energy that mimics the processes powering the sun. Fusion power promises to revolutionize the energy sector and combat climate change without greenhouse gas emissions. Meanwhile, the James Webb Space Telescope continues to challenge cosmological models by detecting massive impossible galaxies formed just 200 million years after the Big Bang, with masses 100 times that of the Milky Way. Such findings compel scientists to revisit the standard model of particle physics and the prevailing theories of cosmic evolution, questioning our fundamental understanding of the universe. On the International Space Station, the Cold Atom Lab has observed quantum entanglement phenomena between atoms separated by 1.5 meters in microgravity, laying groundwork for a quantum internet with speeds and security far beyond current capabilities. These scientific advancements are woven into a complex knowledge network. Astrophysics drives quantum technology, novel materials revolutionize medicine, and AI transforms archaeology. This is the essence of intellectual evolution a process of endless resonance where each breakthrough becomes a lever for others. Humankind, a product of 13.8 billion years of cosmic evolution, is progressively becoming the universe's interpreter and shaper. From interstellar dust to the loftiest human concepts, everything is part of an eternal flow of knowledge, a journey of ceaseless exploration and understanding of our cosmic home. This vast and intricate mesh of scientific progress, far from being a mere coincidence of parallel discoveries, reveals the profound interdependence of knowledge domains that feed into one another, forming a grand intellectual ecosystem. The progress of quantum science, for instance, has not been possible without breakthroughs in understanding the cosmos, such as the mechanisms of stellar phenomena and cosmic radiation. Conversely, innovations in quantum computing and measurement techniques empower astrophysicists to probe deeper into space-time fabric, dark matter, and the early universe's conditions. This reciprocal relationship underscores a broader principle that no scientific field develops in a vacuum. Each step forward in one arena frequently triggers waves of transformation in others. In medicine, the advent of novel biomaterials, often born from quantum and nanoscience research, has revolutionized diagnostics and therapeutics. Materials with programmable molecular structures can now adapt dynamically to the environment inside the human body, providing unprecedented control over drug delivery systems, tissue engineering, and even artificial organs. This integration between physics, chemistry, and biology reflects the synergistic character of contemporary science, where boundaries blur and disciplines merge, opening avenues for breakthroughs impossible to predict from isolated efforts. Artificial intelligence represents another pillar in this evolving matrix. Initially developed to solve problems within computer science, AIS methodologies have now permeated numerous fields, including archaeology, where machine learning algorithms analyze vast amounts of data to reveal hidden patterns in artifacts, inscriptions, and historical site structures. Such applications breathe new life into the study of human history, enabling reconstructions of lost civilizations and insights into cultural evolution that were previously unattainable. Humanity's role in this sprawling narrative is both extraordinary and humbling. Born from a chain of cosmic events spanning nearly 14 billion years, from the primordial particles emerging from the Big Bang to the complex molecules forming life on Earth, humans now stand at a crossroads. Equipped with intelligence, curiosity, and technology, we not only decode the universe's secrets, but also wield the power to influence its unfolding. This transformation from passive observers to active participants in cosmic evolution frames a new chapter in both science and philosophy, raising profound questions about destiny, responsibility, and the nature of existence. Zooming out to the cosmic scale, the discovery of filamentary structures connecting galaxies reshapes our understanding of the universe's large-scale architecture. These gaseous threads, tenuous yet immense, constitute the cosmic web, an enormous framework that determines the distribution of matter and the flow of energy on the grandest scales. The presence of such filaments containing the bulk of baryonic matter finally solves a long-standing problem in cosmology: the whereabouts of the so-called missing baryons. Beyond accounting for matter, These structures provide insight into the dynamics of galaxy formation and the influence of dark matter and dark energy on cosmic evolution. Simultaneously, the emergence of quantum supermolecules, complex assemblies where quantum coherence extends across numerous atoms, challenges our foundational understanding of matter. These hybrid states blur classical categorizations, suggesting the existence of phases of matter with extraordinary properties. The potential for smart materials that respond adaptively to external stimuli revolutionizes fields ranging from medicine to construction. For example, materials that alter their mechanical or thermal properties on demand could lead to buildings that withstand natural disasters by adjusting their structure in real time, or implants that mimic biological tissues more closely, reducing rejection and improving patient outcomes. At the planet's most extreme environments, life continues to surprise us. The Mariana Trench, long considered one of Earth's final frontiers, hosts ecosystems thriving in near total darkness and crushing pressure, powered not by sunlight but by chemical energy derived from geological processes. This chemosynthesis-driven biosphere expands our conception of life's resilience and adaptability, influencing astrobiology and the search for extraterrestrial life. If microbes can flourish in such inhospitable conditions, it bolsters the plausibility of life existing beneath the ice-covered oceans of moons like Europa or Enceladus. Moreover, the enzymatic capabilities of these deep-sea bacteria to break down plastic pollution at accelerated rates offer a beacon of hope amid a global environmental crisis. The plastic waste accumulating in oceans and landfills poses a threat to ecosystems and human health alike. Thus, biotechnological solutions derived from nature's own processes could transform waste management, reducing environmental impact and enabling circular economies. Meanwhile, AI's transformative influence in biomedicine cannot be overstated. Tools like AlphaFold have revolutionized structural biology by predicting protein folding and interactions with nucleic acids with unparalleled accuracy. This leap facilitates drug discovery processes, shortening the time from concept to clinical application dramatically beyond speeding development. AI-driven protein design enables the creation of novel enzymes and therapeutic agents tailored for specific purposes, such as breaking down stubborn pollutants or targeting disease pathways with high precision. Energy research has similarly witnessed monumental advances. Nuclear fusion, the process powering stars, promises a clean and virtually inexhaustible energy source. The spark reactor's successful containment of ultra-hot plasma for extended periods marks a turning point in the quest to replicate stellar fusion on Earth. Unlike fission, fusion produces minimal radioactive waste and no greenhouse gases, addressing both energy demands and environmental concerns. If harnessed successfully at scale, fusion energy could revolutionize global power generation, stabilize economies, and mitigate climate change impacts. Astrophysical observations continue to challenge established cosmological models. The James Webb Space Telescope's detection of unexpectedly massive and mature galaxies from the universe's infancy pushes back the timeline for galaxy formation and questions the sufficiency of current theoretical frameworks Such anomalies compel scientists to refine or rethink fundamental assumptions, potentially revealing new physics beyond the standard model or uncovering previously unknown cosmic mechanisms. On board the International Space Station, experiments with ultra-cold atoms in microgravity have achieved entanglement over unprecedented distances. This progress lays the foundation for a quantum internet capable of transmitting information with security and speed far exceeding classical networks. The implications for communication, cryptography, and computing are profound, heralding a new era of technological capabilities. Together, these advancements form a multifaceted mosaic, each piece interlocking with others to push the frontier of human knowledge. The evolution of science is not a linear progression, but a symphony of interconnected discoveries, where insights from one field accelerate breakthroughs in another. This synergy exemplifies the collective nature of human inquiry, underscoring that the future of knowledge belongs to those who embrace interdisciplinary collaboration and the integration of diverse perspectives. In this grand tapestry, humanity is both a product and an agent of cosmic evolution. Our species embodies the universe's capacity to reflect upon itself, to decode its mysteries, and ultimately to influence its course. As we continue to unravel the threads of the cosmos and innovate at the boundaries of possibility, we are called to consider not only what we can achieve, but also how we choose to wield this power. The unfolding story of science is also a story of stewardship and invitation to shape a future in harmony with the universe's vast and delicate complexity. Over the course of the last century, the tapestry of scientific knowledge has evolved not as isolated threads, but as an intricately woven network, where progress in one domain ignites breakthroughs in others. This interconnected web of understanding spans from the infinitesimal particles dancing within atoms to the sprawling cosmic structures that stretch billions of light years across the universe. The quantum leaps in physics, the revolutionary strides in biology, the advances in artificial intelligence, and the uncovering of ancient histories all form the facets of a unified journey, humanity's relentless pursuit of knowledge. Consider the profound implications of quantum technology, which owes much of its momentum to deeper insights gleaned from astrophysics. The exploration of celestial phenomena reveals fundamental principles that inform the development of quantum computers and sensors, pushing the boundaries of what machines can achieve. These machines, in turn, accelerate the decoding of biological processes, opening unprecedented pathways for medical innovation. For instance, new materials engineered at the quantum level provide the scaffolding for implants and prosthetics that adapt to the human body in real time, optimizing healing and performance. On another frontier, artificial intelligence transcends its initial confines, weaving itself into fields as diverse as archaeology and environmental science. AI algorithms now sift through vast data sets, revealing hidden patterns in ancient ruins, suggesting previously unknown cultural connections. Simultaneously, these technologies enable the rapid identification and synthesis of enzymes capable of breaking down stubborn pollutants like plastics, thus presenting hopeful solutions to the global crisis of waste. Deep beneath the ocean's surface, at the Mariana Trench's unfathomable depths, Life thrives where it was once thought impossible. Microbial communities harness energy from geological processes independent of sunlight, demonstrating nature's astonishing adaptability. This discovery reframes our understanding of life's boundaries and fuels speculation about ecosystems beneath the icy crusts of moons like Europa, igniting the search for extraterrestrial life within our solar system. In parallel, humanity's gaze extends ever outward. Space telescopes equipped with cutting-edge instruments detect vast filaments of hot, tenuous gas, the cosmic web, that bind galaxies together in a colossal structure spanning the observable universe. These filaments, invisible to optical telescopes, contain most of the universe's ordinary matter, a revelation that solves a long-standing mystery in cosmology and reshapes our view of the cosmos as a living, dynamic network rather than a collection of isolated islands. Meanwhile, the quest for sustainable energy advances with remarkable progress in nuclear fusion technology. Devices capable of sustaining ultra-hot plasmas long enough to produce net positive energy output promise a future where humanity harnesses the power of the stars. The implications are staggering. Nearly limitless clean energy, a decisive blow to fossil fuel dependency, and a potential turning point in combating climate change. Amid these monumental strides, the role of humans morphs into that of storytellers, interpreters, and architects of the universe's unfolding narrative. Born from a 13.8 billion-year evolutionary saga, we are uniquely positioned to decode the cosmic messages inscribed in matter and energy, to synthesize knowledge across disciplines, and to wield this understanding responsibly. The essence of this journey is not mere accumulation of facts, but the continuous interplay, the symphony of discovery, where each breakthrough is a note harmonizing with others to create an ever richer composition. In this grand concert of existence, technology acts both as an amplifier and a bridge. For example, the refinement of quantum states into supermolecules, exotic forms of matter with hybrid characteristics of solids, liquids, and gases ushers in an era of materials that can dynamically adjust to environmental demands. Applications span medical devices that respond instantly to physiological changes, building materials that adapt to seismic forces, and electronic gadgets that morph functionally based on user needs. These innovations exemplify how quantum physics transcends theory to shape tangible, transformative tools. Concurrently, breakthroughs in protein folding algorithms revolutionize drug discovery, compressing what was once decades of research into months. AI-powered platforms predict not only the shapes of proteins, but also their complex interactions with genetic material, enabling the design of novel biomolecules tailored to degrade pollutants, fight diseases, and optimize metabolic pathways. This paradigm shift accelerates our ability to confront pressing challenges and opens avenues for creative biological engineering. The cosmic web itself, revealed through sophisticated X-ray observatories, highlights the dynamic, interconnected nature of matter and energy flow at scales incomprehensible to human intuition. Energy pulses ripple through these colossal filaments, influencing galaxy formation and evolution, illuminating the universe's life cycle as an integrated system. This perspective invites a new understanding of cosmology, not as the study of isolated phenomena, but as the science of a living network where everything impacts everything else. Back on Earth, microbial ecosystems thriving in extreme environments challenge our assumptions about life's resilience and versatility. Their metabolic processes, powered by chemical reactions within Earth's mantle, defy traditional models that tie life to sunlight. The implications extend beyond Earth's biosphere, providing templates for potential life forms on other worlds and suggesting strategies for bioengineering microbes to mitigate environmental damage, such as accelerated breakdown of plastics, thus addressing the mounting crisis of pollution. Through all these interwoven developments, the narrative of knowledge progression is clear. No discovery stands alone. Instead, it sparks a chain reaction, propelling other fields forward, forging unexpected connections, and creating a robust, evolving framework of understanding. As we navigate this landscape, our collective endeavor is to harness these insights ethically, ensuring that progress uplifts humanity and respects the intricate balances sustaining life and the cosmos. Ultimately, the journey from stardust to sentience encapsulates a saga of transformation. The elementary particles born in the Big Bang coalesced into stars and galaxies, which in turn seeded planets where life emerged, evolved, and began to reflect upon its own existence. This recursive process of self-awareness, the universe knowing itself through conscious beings, is perhaps the most profound discovery of all. It underscores our role not merely as passive observers, but as active participants shaping the destiny of the cosmos. Thus, our story is one of endless creativity and discovery, a testament to the power of curiosity and the indomitable human spirit. From quantum realms to cosmic filaments, from microscopic bacteria to towering civilizations, the web of knowledge continues to expand, intertwining science, technology, and philosophy. It is within this rich matrix that humanity finds its purpose, to explore, understand, and ultimately to become the stewards of the universe's grand design. The evolution of human knowledge is a complex tapestry woven from countless threads of discovery, innovation, and insight. Scientific advancements never exist in isolation. Rather, they intertwine, each new breakthrough amplifying others across disciplines to form an ever more intricate network of understanding. This interdependency drives the accelerating pace of progress, where advances in one field catalyze revolutions in another, creating a dynamic and continuous symphony of intellectual growth. One of the most striking examples of this synergy is found in the relationship between quantum technology and astrophysics. Our deepening grasp of the cosmos has provided foundational insights that propel quantum mechanics into new realms. Through the lens of advanced telescopes and cosmic observation, scientists uncover phenomena that challenge and refine quantum theories, leading to the creation of new materials and devices that harness quantum effects in unprecedented ways. Similarly, medicine has undergone transformative shifts powered by innovations in material science. The development of novel biomaterials has enabled therapies and medical devices that adapt dynamically to the human body, improving treatment outcomes and patient quality of life. These materials often rely on principles derived from condensed matter physics, chemistry, and nanotechnology, fields themselves evolving rapidly due to computational modeling advancements and experimental breakthroughs. Artificial intelligence (AI) exemplifies the cutting edge of this knowledge interplay. The application of AI in archaeology, for instance, is revolutionizing how we uncover and interpret human history. Machine learning algorithms analyze vast troves of data, identifying patterns invisible to human researchers, accelerating the pace of discovery, while also opening new questions about cultural evolution and human behavior. This convergence of computing power, statistical analysis, and domain-specific knowledge is reshaping entire academic disciplines. This interconnectedness is the essence of knowledge evolution, a ceaseless process of resonance where each breakthrough acts as a lever, propelling progress in other domains. As this process unfolds on the grand scale of the cosmos, humans, themselves the product of 13.8 billion years of cosmic evolution, assume new roles as storytellers, decoders, and, perhaps soon, architects of the universe's destiny. From the smallest interstellar dust particles to the grandest human ideas, from the simplest chemical reactions in ancient oceans to the most sophisticated quantum supercomputers, all participate in this eternal current of creativity, exploration, and understanding. The grandest story ever told continues to be written daily, fueled by humanity's relentless quest to explore and comprehend the cosmic home we inhabit. Recent astronomical observations illustrate the dynamic, living nature of the cosmos. The latest X-ray telescopes have mapped vast filaments of hot, diffuse gas spanning millions of light years, the so-called cosmic web that links the largest structures in the universe. These filaments contain baryonic matter 10 times the combined mass of all galaxies, solving the long-standing puzzle of the missing matter that had eluded detection for decades. More astonishingly, data from the Rosetta mission reveal how energy flows through this intricate network, painting a picture of the universe as a vibrant, interconnected web rather than isolated islands of galaxies. Meanwhile, breakthroughs in quantum physics laboratories have unveiled entirely new states of matter. The creation of quantum supermolecules, clusters of hundreds of atoms sharing a collective quantum state in 3 dimensions, challenges current condensed matter theories. These supermolecules exhibit characteristics of solids, liquids, and gases, simultaneously heralding a new frontier in material science. Their tunable properties promise revolutionary applications, from adaptive biomaterials in medicine to earthquake-resistant structural components, and from room temperature superconductors powering energy grids to multifunctional consumer electronics. Deep beneath Earth's surface in the Mariana Trench, scientists have discovered thriving communities of ancient bacteria at depths exceeding 11,000 meters, surviving pressures that would crush modern submarines. These organisms rely not on sunlight, but on chemical energy generated by serpentinization, a reaction between mantle rock and seawater. This discovery expands the known boundaries of life on Earth and supports hypotheses about life existing beneath the icy crusts of moons like Europa. Remarkably, these microbes produce enzymes that degrade plastics at rates 5 times faster than surface bacteria, offering promising solutions for the global plastic pollution crisis. Artificial intelligence continues to revolutionize biomedical science. The AlphaFold for algorithm not only predicts protein structures with unprecedented accuracy, but also models their interactions with DNA and RNA. This breakthrough accelerates drug discovery timelines from a decade to mere months and enables the design of entirely novel proteins. One remarkable application is the engineered enzyme capable of breaking down PET plastics within 24 hours compared to 450 years naturally, a game changer in waste management and energy research. The spark fusion reactor marks a milestone by sustaining plasma at 200 billion degrees Celsius for 55 seconds, producing 10 times more energy and input. This leap toward practical nuclear fusion mimics the sun's energy generation, promising a clean, virtually limitless power source. If realized, fusion could revolutionize global energy systems, drastically reducing carbon emissions and combating climate change. The James Webb Space Telescope challenges foundational cosmological models by detecting massive galaxies that existed just 200 million years after the Big Bang, some with masses 100 times greater than the Milky Way. These findings force scientists to reconsider the timeline and mechanisms of galaxy formation and question the completeness of the standard model of particle physics. On the International Space Station, the Cold Atom Lab achieved a quantum entanglement experiment between atoms separated by 1.5 meters under microgravity. This success paves the way for space-based quantum communication networks, potentially enabling internet speeds and security far beyond terrestrial capabilities. These advancements do not stand alone, but form a vast, interconnected matrix of knowledge. Astrophysics fuels quantum technology. New materials revolutionize medicine. AI transforms archaeology. This is the core of knowledge evolution, an ongoing interplay where each discovery propels the next. Humankind, shaped by 13.8 billion years of cosmic history, increasingly becomes the interpreter and shaper of the universe's fate. From stardust to profound ideas, all are part of this endless stream of knowledge, a journey of perpetual exploration and understanding of the universe we call home. From a singularity smaller than any grain of sand, the universe erupted in an unimaginably vast expansion, temperatures reaching 1032 Kelvin, infinite matter density, and the four fundamental forces of nature unified as one. Within the first 10 to 36 seconds, cosmic inflation expanded spacetime exponentially, seeding quantum fluctuations that would eventually form galaxies. As the universe cooled, quarks and gluons combined into protons and neutrons. Then atomic nuclei formed through Big Bang nucleosynthesis. A tiny imbalance, just 1 part in a billion between matter and antimatter, allowed our material universe to persist. 380,000 years later, electrons were captured by nuclei to form neutral atoms, releasing the cosmic microwave background radiation CMB we observe today. For the next 200 million years, the universe lay in darkness until the first star's population 3 ignited from primordial gas, reionizing the cosmos with their intense ultraviolet radiation. These massive stars lived fast and died young, exploding as brilliant supernovae, releasing the first heavy elements like carbon, oxygen, and iron, the raw materials for future stars and planets. In a humble corner of the Orion arm of the Milky Way galaxy, a cloud rich in heavy elements began to collapse under gravity, giving rise to our solar system 4.6 billion years ago. As the cloud spun, most of its mass gathered at the center to form the young sun, while the rest flattened into a protoplanetary disk. Dust grains collided and stuck together from micron-sized particles to pebbles, to boulders, and finally to protoplanets. Earth formed at the perfect distance from the sun, not too close to evaporate water, not too far to freeze it permanently. A late heavy bombardment delivered vast amounts of water via meteorites, forming primordial oceans. A massive collision with a Mars-sized body they created the Moon, an unusually large satellite that stabilizes Earth's axial tilt, and deep-sea volcanic vents. At geothermal fissures spewing mineral-rich hot water, complex organic molecules began to form. Primitive RNA appeared, followed by the first self-replicating cells. Life began its 3.8 billion-year journey, from simple bacteria to complex multicellular organisms, from sea to land, from the colossal reptiles of the Mesozoic era to the tiny mammals that survived the asteroid impact 66 million years ago. A unique evolutionary branch emerged: primates, then hominids, then Homo sapiens with vastly developed brains. We stood upright, freeing our hands to craft tools, developed language to share complex ideas, created art to express emotion. Small communities became tribes, villages, cities, and nations. We mastered fire, practiced agriculture, built civilizations, gazed at the starry night sky, and asked questions about our origin. Science was born, a method to decode nature's mysteries. Galileo turned his telescope skyward. Newton formulated the law of gravitation. Einstein proposed relativity, and Hubble discovered the expanding universe. We decoded DNA, split the atom, walked on the moon, and sent probes to the edge of the solar system. The Hubble telescope captured galaxies from the dawn of time. The LHC recreated the moments after the Big Bang. Yet perhaps our greatest discovery is that we are part of this grand story. When you breathe, the oxygen atoms have passed through countless ancient lungs. When you touch a tree, you touch a being with a common ancestor from billions of years ago. When you look at the night sky, the light from distant stars has traveled thousands of years just to meet your eyes in this moment. And the story continues. We now stand at the threshold of a new era when artificial intelligence may surpass human intelligence, when biotechnology may allow us to redesign our very bodies, when we prepare to become a multiplanetary civilization. Yet, no matter how far technology advances, what defines us as human still our capacity for love, creativity, empathy, and dreams. You are the result of 13.8 billion years of cosmic evolution, of 4.5 billion years of Earth's shaping, of millions of years of human development. Every cell in your body contains that story. Every thought and feeling is a ripple in the vast river from the Big Bang to consciousness. When you love, when you create, when you strive for goodness, you are helping write the next chapter in the greatest story ever told, the story of the universe awakening to itself. A story with no end, a journey without limits, a symphony of matter and mind, of stars and souls, of past and future, all intertwined in a complex and beautiful web we are only beginning to understand. And in that exploration, in that yearning to know, in that passion to discover lies the true meaning of existence, of the universe, of Earth, and of ourselves. Keep going, keep exploring, keep loving, because you are how the universe perfects itself, the light finding its way through the darkness, the future being shaped in this very moment. And whoever you are, wherever you may be, remember, you are an inseparable part of this grand story, a story we write together each day, with every thought, every action, every dream. Meanwhile, in the world's most advanced quantum physics laboratories, scientists have created a completely new state of matter, quantum supermolecules, where a group of atoms shares the same quantum state in three-dimensional space, simultaneously exhibiting properties of solids, liquids, and gases. This bizarre phenomenon not only challenges our current understanding of condensed matter physics, but also opens the door to developing entirely new materials capable of changing their properties in our real time upon demand. On Earth, biologists had just announced a groundbreaking discovery, an entirely new ecosystem of bacteria thriving at a record depth of 11,000 meters in the Mariana Trench. Astonishingly, they survive without sunlight or organic matter from above, instead relying on chemical reactions between mantle rock and seawater. This discovery not only expands the boundaries of life on Earth, but also strengthens the hypothesis of life potentially existing beneath the icy surfaces of moons like Europa or Enceladus. Artificial intelligence is revolutionizing medicine. The latest AlphaFold for system can accurately predict not only the structure of proteins, but also how they interact with DNA, RNA, and small molecules. This breakthrough has shortened drug development timelines from 10 years to just a few months and enables the design of entirely new proteins to tackle global challenges like climate change and pollution. In the energy sector, the spark fusion reactor has achieved a critical breakthrough, maintaining plasma at 200 million degrees Celsius for a record 55 seconds, with an energy output 10 times greater than the input. This success marks a decisive step toward harnessing the infinite clean power of nuclear fusion, the same process that fuels the sun. The James Webb Space Telescope continues to upend our understanding of the early universe by discovering monster galaxies that formed far earlier than current models allow. These galaxies, existing just 200 million years after the Big Bang and boasting masses 100 times greater than the Milky Way, are forcing cosmologists to reconsider the very foundations of cosmic structure formation and even question the completeness of the standard model of particle physics. On the International Space Station, the Cold Atom Lab has, for the first time, observed quantum entanglement between atoms separated by 1.5 meters in microgravity. This achievement paves the way for the development of space-based quantum communication networks, the foundation for a global quantum internet with speed and security far beyond any existing technology. These scientific advances do not exist in isolation. that weave together into an increasingly complex web of knowledge. Every discovery, no matter how small, helps complete the grand puzzle of our origins and future in the vast cosmos. And in this magnificent float, humanity born from 13.8 billion years of cosmic evolution is becoming the narrator, the decoder, and perhaps soon the architect of the universe's destiny. Among the giant molecular clouds drifting between the stars, astronomers have discovered a special sugar molecule called glycolaldite, a chemical building block of RNA. Miraculously, these molecules form naturally on the surfaces of interstellar dust grains at minus 163 degrees Celsius, proving that the ingredients for life are widespread across the universe. Nearby in the Orion Nebula, methyl isocyanate, a crucial precursor to peptides, has also been found, suggesting that the universe had already prepared everything necessary for life billions of years before Earth even formed. In modern laboratories, scientists have successfully recreated co-servant droplets, the first pre-cellular structures capable of self-division. These tiny droplets, composed of peptides and RNA, can absorb nutrients, grow, and divide like living cells. Even more astonishing, they exhibit primitive bioelectrical signals, hinting that consciousness might have emerged from the simplest of structures. In the depths of the ocean, researchers have uncovered an entirely new world at hydrothermal vents over 10,000 meters deep, where pressure is enough to crush conventional submarines. Exists a vibrant bacterial ecosystem powered by chemical reactions between rock and seawater. These ancient organisms require neither sunlight nor oxygen, and produce enzymes capable of degrading plastic 5 times faster than any known surface bacteria, a priceless gift from nature in the fight against environmental pollution. Meanwhile, on Mars, the Perseverance rover has uncovered undeniable evidence of a wet past. The oldest rock samples ever collected show signs of clay minerals and complex organic compounds, clear indicators of a long-standing lake billions of years ago. On Europa, one of Jupiter's moons, scientists eagerly await upcoming missions to search for life in the vast subsurface ocean beneath its thick, icy crust. As for humanity, we now stand on the threshold of awe-inspiring possibilities. CRISPR, our gene-editing technology, now in its 3rd generation, allows for precise changes to individual DNA bases without damaging the double helix. This has already cured sickle cell anemia in primate models and promises to revolutionize medicine in the coming decade. Artificial intelligence continues to advance. AlphaFold for now predicts not only protein structures, but also how they interact with other molecules. One remarkable application is a newly designed enzyme that can degrade plastic waste in just 24 hours, of potential solution, one of humanity's most urgent environmental crises. The spark fusion reactor has achieved a milestone by sustaining plasma at 200 million degrees Celsius for 55 seconds, an essential leap toward mastering the infinite clean energy fusion. Mimicking the power generation of the sun, this success could redefine global energy in the decades to come. The James Webb Space Telescope continues to challenge our understanding of the cosmos with its discovery of impossible galaxies, too massive and to evolve for their age. These observations threaten to upend current cosmological theories and may spark revolution in our understanding of how the universe formed and evolved. On the ISS, the Cold Atom Lab has created the exotic Bose-Einstein condensate in microgravity, a state where thousands of atoms behave as a single quantum entity. This breakthrough not only enables the study of quantum effects on a macroscopic scale, but also opens the door to entirely new quantum technologies. These advances are not isolated phenomena, they are pieces of the grand story of the universe's evolution from the Big Bang to consciousness. They show that we are not passive observers, but active participants in this ongoing journey. Every discovery and invention brings us closer to solving the universe's deepest mysteries and understanding our place within it. And so, the greatest story ever told continues to be written every day through the tireless efforts of all humanity. From the tiniest specks of interstellar dust to the grandest ideas in the human mind, all are threads in this eternal flow, the flow of creativity, discovery, and understanding. In the seemingly empty space between galaxies, scientists have uncovered massive dark matter filaments, the cosmic backbone. Stretching millions of light years, these invisible structures contain 10 times more matter than all the observable galaxies combined. Modern X-ray telescopes have captured images of hot, rarefied gas glowing brilliantly, revealing how energy is distributed across the cosmos. This discovery not only solves the mystery of the missing baryonic matter, but also shows that the universe is connected by a far more intricate network than we ever imagined. These scientific advances do not exist in isolation, but intertwine to form an increasingly complex web of knowledge. Quantum technology progresses thanks to deeper understanding of astrophysics. Medical breakthroughs emerge for new materials engineering. Archaeology advances through AI technology. This is the essence of knowledge evolution, a continuous resonance process where each step forward in one field becomes a lever for another. And within this grand flow, humanity, product of 13.8 billion years of cosmic evolution, is gradually becoming the storyteller, the decoder, and perhaps one day soon, the shaper of the very fate of this universe. From tiny dust particles between stars to the greatest ideas in the human mind, from simple chemical reactions in ancient oceans to modern quantum supercomputers, all are part of this eternal stream, the stream of creativity, discovery, and understanding. Thus, the greatest story ever told continues to be written daily through the relentless efforts of all humanity in the journey to explore and comprehend the universe we call home. In the seemingly empty void between galaxies, the latest X-ray telescopes have detected vast filaments of hot, diffuse gas millions of degrees in temperature, stretching across millions of light years, the cosmic backbone linking all large-scale structures. These matter filaments contain 10 times the baryonic mass of all galaxies combined, solving the two-decade mystery of the missing matter. More intriguingly, data from Rosetta reveal how energy propagates throughout the universe via this intricate network, showing that the cosmos is a far more dynamic web than the isolated galaxies we once imagined. Meanwhile, in quantum laboratories, physicists have created a completely new state of matter, a quantum supermolecule, where hundreds of atoms share the same quantum state in three-dimensional space, exhibiting properties of solids, liquids, and gases simultaneously. This unprecedented phenomenon challenges all current theories of condensed matter physics and opens pathways for smart materials that can adapt their properties on demand in real time. Potential applications range from medicine self-adjusting biomaterials to construction earthquake adaptive structures, from energy technology room temperature superconductors to consumer electronics multifunctional devices. At the bottom of the Mariana Trench, scientists have discovered an ancient bacterial ecosystem thriving at the record-breaking depth of 11,000 meters, where pressure is enough to crush military submarines. Astonishingly, these bacteria live entirely independently of sunlight, instead harnessing energy from serpentinization reactions between mantle rock and seawater. This discovery expands the known limits of life on Earth and strengthens hypotheses about life beneath the icy surfaces of moons like Europa. Notably, they produce enzymes that degrade plastics at 5 times the speed of surface bacteria, promising solution to the global plastic pollution crisis. AI technology is revolutionizing medicine, with AlphaFold for not only accurately predicting protein structures, but also their interactions with DNA and RNA. This achievement has reduced drug development time from 10 years to just months and enables the design of entirely new proteins. The most impressive application is an enzyme capable of breaking down PET plastic in 24 hours compared to 450 years naturally, a breakthrough in plastic waste treatment. The spark fusion reactor achieved a milestone by sustaining plasma at 200 million degrees Celsius for 55 seconds, generating 10 times the input energy, a critical step toward limitless clean energy that mimics the sun's operation. This technology promises to revolutionize the energy sector and solve the climate crisis without emissions. The James Webb Space Telescope continues to overturn cosmology by discovering impossible galaxies formed only 200 million years after the Big Bang, yet 100 times more massive than the Milky Way. This finding forces scientists to reconsider the entire theory of cosmic formation, even questioning the completeness of the standard model of particle physics. On the International Space Station, the Cold Atom Lab experiment has, for the first time, observed quantum entanglement between atoms separated by 1.5 meters in microgravity, paving the way for space-based quantum communication networks, the foundation of an internet with unprecedented speed and security. These advances weave together into a complex network of knowledge: astrophysics propelling quantum technology, new materials revolutionizing medicine, AI breakthroughs accelerating archaeology. This is the essence of knowledge evolution, a continuous resonance, where each breakthrough becomes a lever for another. Humanity, the product of 13.8 billion years of cosmic evolution, is gradually becoming the decoder and shaper of the universe's destiny. From interstellar dust to the greatest ideas, all are parts of this eternal current of knowledge, the unending journey of discovery and understanding of our cosmic home. From a singularity smaller than any grain of sand, the universe erupted in an unimaginably vast expansion, temperatures reaching 1032 Kelvin, infinite matter density, and the 4 fundamental forces of nature unified as one. Within the first 10 to 36 seconds, cosmic inflation expanded spacetime exponentially, seeding quantum fluctuations that would eventually form galaxies. As the universe cooled, quarks and gluons combined into protons and neutrons. Then atomic nuclei formed through Big Bang nucleosynthesis. A tiny imbalance, just 1 part in a billion between matter and antimatter, allowed our material universe to persist. 380,000 years later, electrons were captured by nuclei to form neutral atoms, releasing the cosmic microwave background radiation CMB we observe today. For the next 200 million years, the universe lay in darkness until the first star's population 3 ignited from primordial gas, ionizing the cosmos with their intense ultraviolet radiation. These massive stars lived fast and died young, exploding as brilliant supernovae, releasing the first heavy elements like carbon, oxygen, and iron, the raw materials for future stars and planets. In a humble corner of the Orion arm of the Milky Way galaxy, a cloud rich in heavy elements began to collapse under gravity, giving rise to our solar system 4.6 billion years ago. As the cloud spun, most of its mass gathered at the center to form the young sun, while the rest flattened into a protoplanetary disk. Dust grains collided and stuck together from micron-sized particles to pebbles, to boulders, and finally to protoplanets. Earth formed at the perfect distance from the sun, not too close to evaporate water, not too far to freeze it permanently. A late heavy bombardment delivered vast amounts of water via meteorites, forming primordial oceans. A massive collision with a Mars-sized body they created the Moon, an unusually large satellite that stabilizes Earth's axial tilt, and deep-sea volcanic vents. At geothermal fissures spewing mineral-rich hot water, complex organic molecules began to form. Primitive RNA appeared, followed by the first self-replicating cells. Life began its 3.8 billion-year journey